So, welcome to our next video. This is going to be about slopes of curves and how that links in with our previous video about limits, because it seems like completely different topics at first, but we'll see that shortly. Now, how do you find the slope of a curve? Well, we've got an immediate problem, which is that if we measure the slope here, it seems to be around negative. Here, it's flat-ish. And here it's positive, okay, it's going upwards. Okay, so what we find is that the slope is changing depending on the x value in this function. So that seems to be different than what you learned many years ago about straight lines, how we can just find the change in y over change in x from two different points, any 2 points, and that will tell you the slope, okay, the rise over run, the gradient. Okay, so, well, let's narrow down on at least 1 point, okay? We know it changes, but can we even find the slope at x equals 2, for example? Okay, now can we use the same method as the picking 2 points and doing rise over run? Well, if I pick this point here, okay, I can draw the line between them. I could find the rise over run. But if I could just pick any other point here, and I'd have a line between those, and that would be different. Okay, so we can't have different slopes, and indeed this method just isn't applicable at all. Okay, so we can't really have 2 points. So what do we do instead? Well, we have what is called a tangent. Okay, this is a straight line that just touches this curve at the exact point that we are talking about, at x equals 2, and does not touch the curve at any other point in the immediate vicinity of our target point. And now we have a straight line, we can now find the slope. Okay, and we're not going to do anything too technical here. I'm just going to say that this slope seems to be roughly 0. Okay, flat. Okay, now what if we've got another point here at x equals 5, for example? Well, we can again draw a tangent. Okay, it is quite hard to get this very accurate, and we'll come back to that in a second. But let's say that is a tangent for x equals 5. I could find the slope of this, and let's say that that is roughly 2 over 3, 2/3. This slope might be positive 2/3. Okay. Now, you may have seen one major problem there, which was that how do we exactly do this tangent? Okay, and surely if we had to draw this tangent, how do we know if it was the one that I drew, or maybe something slightly different? Okay, slightly different in this way. That still looks like it's only touching the curve at 1 point, but it's giving well, quite significantly different answers for the slope of those potential tangents. Okay, so really, we want to know what exactly does a tangent refer to? Does it have a sort of technical definition? And it does. Okay, so let's go back to attempting what we did first, okay, which was a tangent that was, well, a straight line that went between 2 points. Okay, and this is not going to be what we end up with here, but that's just our starting point. Okay, I've got x1 as the point where we want to find our slope. And I've got another point, let's say this gap between x1 and this x coordinate. Let's call that gap h. Okay, and what we want to do here is we want to eventually get to the tangent. Okay, so clearly this point, this green point, needs to come closer to the red point. Okay, and if we move it closer as so, then we have a new tangent that is getting closer to the actual tangent that would be correct. Okay, and we're still going to call this h, this gap here. Okay, so how do we actually end up with a tangent? Clearly I need to keep moving this way with our green point. Okay, but it's still going to be two separate points. Unless we say that we make this gap, h, tend towards 0. Okay, so it's almost infinitesimally small. Infinitely small. Okay, so this green point gets closer and closer and closer and closer until there's an infinitely small gap. Okay, and that would represent the tangent, okay, or the limit of the tangent as that point gets closer and closer. Okay, but how do we represent that algebraically? Well, we need to know how we would find the slope of all of these potential tangents. Well, we can do this rise over run from here to here. Okay, the rise, well, this y-coordinate we could call f of x1. The y-coordinate of the green point we could call f of x1 plus h. Okay, and those would be our y-coordinates. Okay, so that's the change in y. Okay, and well, what's the change in the x-coordinate? Well, we have x1 plus h here, and we have x1. Okay, so we subtract to find the difference. Okay, and that would be the slope of any of one of those tangents. Okay, but we want this h number to tend towards 0, to keep getting smaller and smaller. Okay, and we want the limit of this gradient, the slope, as h does just that, as it tends towards 0. Okay, and what we can do is simplify the bottom of this. Those x1s cancel out, and we have a definition of the slope of the tangent, okay, or a function for the slope of a tangent for any function f of x at any point x1 in this case here. Okay, in our next video you will see how this is applicable. This might be really quite confusing right now, and I wouldn't worry about it too much, especially if you're just a standard level student. Because well, whilst you need to know the background, you need to have at least seen it, you actually won't be working with these limits for the slopes of these tangents for long once in your studies of calculus.